Hello friends, in this video I will explain how to determine the convolution of two CT signals. Convolution integral is one mathematical process useful to predict the output of CT LTI system. Let us see the procedure. In first step we have to determine x of t and h of t of the LTI system, where x of t, that is the input signal, and h of t is the impulse response of that system. In second step, we have to obtain x of tau and h of tau by replacing the independent variable t with the tau, where the tau it is called as a dummy variable. In further process, we have to obtain h of minus tau, which is nothing but the folded version of signal h of tau. Next, we have to shift the h of minus tau along the y-axis, such that if the t is negative, we have to shift the h of t minus tau along the left side, and if the t is positive, then we have to shift the h of t minus tau along the right hand side of the x-axis. In next step, we have to plot the x of t and h of t minus tau along the same graph, and we have to shift the h of t minus tau from minus infinity to plus infinity. And to obtain the convolution, here we are using the convolution integral, that is y of t is equal to integral running from minus infinity up to plus infinity x of tau h of t minus tau d tau. Let us solve one example. Here for a given LTI system, its impulse response h of t is given, which is existing between 0 to 2, and its amplitude is equal to 4, and it is equal to 0 otherwise. Similarly, the input to this system, it is given as x of t is equal to 2, which exists between minus 2 to plus 2, and it is equal to 0 otherwise. So in the first step, we have to plot x of t and h of t. So x of t, which is existing between minus 2 to plus 2, and its amplitude is equal to 2, and h of t, that is equal to 4, which is existing between 0 and 2. In this step, we have to obtain x of t and x of tau and h of tau by replacing the independent variable t with the tau. So here this is the x of tau and this is h of tau. Further, we have to obtain h of minus tau by folding the signal h of tau along the y-axis. So this is the x of tau, and here we are getting the h of minus tau, which is nothing but the folded version of h of tau. Next, we have to plot the x of tau and h of t minus tau along the same graph. Now here we can find that the signal h of t minus tau, it is existing between t minus 2 and t, while the x of tau, which is existing between the minus 2 up to the 2. So these two signals that are not overlapping anywhere. So if we take the integral from minus infinity up to t minus tau, here the h of t minus tau, that will be equal to 0. Similarly, x of tau will be equal to 0. But from the limit t minus 2 up to the t, h of t minus tau, which is existing, which is having value of 4, but x of t is not existing between this range. Similarly, from t up to the minus 2, here none of the signal is existing, that is the h of t minus tau and x of tau is not existing in between this range. But from minus 2 up to 2, here the x of t is existing, but here h of t minus tau, which is not existing. So here, by using the formula for the convolution integral, here we can find that this integral can be solved in this way. So here x of tau is not existing between minus infinity to t minus tau, so that's why the value is equal to 0. Similarly, h of t minus tau, it is not existing in between this limit, so that is again 0. From t minus 2 up to the t, here the h of t minus tau, it is existing, which is having amplitude of 4, but x of tau, it is equal to 0. Further, from t up to minus 2, here none of the signal is existing, and from minus 2 up to t2, here only x of tau, which is existing, having the value of 2, but h of t minus tau, it is equal to 0. And in the same way, from the t up to the plus infinity, x of t and h of t minus, x of tau and h of t minus tau, it is not existing over here. So finally, y of t we are getting over here, that is equal to 0 for t less than minus 2. In the next step, we have to shift the t minus tau along the x-axis such that it will intersect the one edge of this x of tau. Now here we have to check out the integral which is existing between minus 2 and minus 1. That is nothing but the overlapping area between the h of t minus tau and x of tau. So here the integral is existing only between the limit minus 2 up to the t. So that's why here x of tau, that is equal to 2, and h of t minus tau, that is equal to 4 in this range. So after calculating this integral, we find that y of t is equal to 8t minus 16. In this step, now we have to shift the h of t minus tau along the x-axis. Now the new limits are t minus 2 up to the t. Now here the signal h of t minus tau and x of tau that are overlapping between the limits of t minus 2 up to the t. So here this is the non-zero part of the integral. So after solving this integral, we are getting y of t, that is equal to 8t minus 8t minus 2, that is equal to 16. Now further, we have to again shift h of t minus tau so that it will intersect the another one edge of this x of tau. So here also the integral that exists between the t minus tau up to the 2. So that's why here solving this integral, we will get that y of t, that is equal to 32 minus 8t. Next, we have to again shift the h of t minus tau. Now in this step, we can find that there isn't any overlap between the x of tau and h of t minus tau. So that's why here the y of t, that becomes equal to 0. In the final step, we have to plot the y of t. So here this is the y of t, that is 8t minus 16, which is between minus 2 up to 0. Second y of t, that is equal to 16 between the 0 up to the 2, and that is equal to 32 minus 8t between 2 and 4. So this is about the convolution of the CT signals. Thank you very much for watching.